Hello and welcome to the final session on string functions. We're going to get started with strcat. And you can see from the prototype, this function returns a character pointer taking as arguments two character pointers, str1 and str2. Returns str1, concatenates a copy of str2 to str1, which means nothing but joining a copy of str2 to str1, terminates str1 with a null character if arrays overlap, behavior is undefined. Remember, as discussed in the last session, if source and destination are within the same string or within the same region of memory, then we need to use memmove. What about the null terminator that originally terminated or ended str1? Well, that would be overwritten by the first character of the second pointer, that's str2. What about str2? Is it altered in any way? No, str2 maintains its integrity, so it will stay the same. Important to note that there's no bound checking done by strcat. It's up to us as programmers to do the same. Coming to strncat, from the prototype, you can see this function again returning a character pointer, but it's got three arguments, the two pointers str1, str2, as well as size t type count. It concatenates or joins not more than count characters of the string pointed to by str2 to the string pointed to by str1, and that there is the difference between strncat and strcat. It terminates str1 with a null, returns str1 if the strings overlap, again behavior is undefined. Remember again, no bound checking done by strncat. Write your own version of strcat. So what we're going to do now is we'll go to code blocks and we'll start a new file. Hashtag include stdio.h and then hashtag include stdlib.h and hashtag include string.h. Right, now what we're going to do first is we're going to just run strcat, the function itself, to see how that works, and then we write our own version. So int main, and we'll have two strings here, char str1, and we'll put that as 100 bytes so that we have enough space to accommodate the second string. And string 2 or str2. Important to have a space there, right? So that when we join these two strings, this starts after the space, right? Now we just run strcat str1, str2, right? So we are saying join str2 to str1, and we can print out the results. So printf str1 %s \n, str1, and then printf, oh, that should be str1 and printf str2 %s \n, str2, and exit 0 to end the program. We just run this now. And you can see how these two strings have been joined together, right? In effect, the second string has been joined to the first. And as you can see, str2 maintains its integrity, stays the same. Now let's write our own. In order to write our own, we'll have to first declare our function here. So char star my strcat, and it will take as arguments, let's say char star s1, char star s2, and that's all, right? Now here, instead of calling strcat, we'll change that to my strcat, right? And we can now proceed to define our function. So char star my strcat, and the arguments will be char star s1, char star S2. We'll have two pointers here. We'll have char star ptr, right? And we'll have star ptr1 as well. ptr will hold the results of running strchr. On the first string, we are looking for the null character. Okay. And ptr1 will be initialized to S2. Right? Now we'll check if not star ptr, right, which means we found the null. Then you see here while star ptr1 not equal to null, and within this we just say star ptr plus plus, right? That means S1 equal to star ptr1 plus plus. Right, so we are moving characters from essentially S2, right? Remember ptr1 is initialized to S2. We are moving them to S1. Not really moving, you can say, just putting in a copy there. Right, and then we can return S1 and S2. Let's run this now. And you can see the concatenation has been done. Right, so that's our version of strcat. Moving on. There's a problem with strcat and strncat. Now, I already spoke about there's no bound checking, right? But most string functions you need to provide for bound checking. But more than that, there are performance issues. So if, for example, 10 strings of 100 bytes each need to be concatenated or joined together. So now talking about the first 100 bytes, when we're looking for the null character, that would require us to look through the first 100 bytes. Total number of searches would be 100 in terms of bytes, right? Or 100 searches, you can see. Now take the next 100 bytes. For the second 100 bytes, we'll have to look through 200 bytes for the null character, right? Add that 200 to the previous 100, we now end up with a total number of searches being 300. Now, if we look at the third 100 bytes, we're going to search the first 300 bytes for the null, right? So the total number of searches will be 300 plus the previous 300 searches, that would be 600. Talk about the fourth 100 bytes, we're going to look through the first 400 bytes now. Add that to 600, that would be 1000 total number of searches. Talk about the fifth 100 bytes. Now we'll need to look through the first 500 bytes for the null. Add that 500 to the previous 1000 total number of searches. That would give us a total number of searches of 1500. Moving on to the sixth 100 bytes. Now we need to look through the first 600 bytes for the null character. Add those together. 600 plus 1500. Total number of searches is now 2100. Right, moving on to the 700 bytes, we'll have to search through the first 700 bytes for the null character. Add that 700 to 2100, we are left with the total number of searches of 2800, and so it keeps mounting up, right? We have the 800 bytes, we're going to look through the first 800 bytes for the null character. Add that 800 to the previous number of searches, which is 2800. And we have total number of searches now to a whopping amount of 3600. Move on to the 900 bytes. We've got to search through the first 900 bytes for the null. Total number of searches will now be 4500. By the time we reach the 10th 100 bytes, or the last 100 bytes that need to be joined, we will need to look through, first of all, 1000 bytes for the null character. The total number of searches would now be 5500. And I've just put a visual here just to make it clear to you. So we have the first 100 bytes. After that, our search is 100, or the total number of searches is 100. Move on to the next 100 bytes. We're searching through 200 bytes now, but add that to the previous 100 and we have 300. Move to the next 100 bytes, right? We're looking through 300 bytes now. Add those together, we have 600 total searches. We have the fourth 100 bytes. Now we're looking through 400. Now the total number of searches, if you add these up, is 1000 already. Talking about the fifth 100 bytes, right? We've got to look through 500, add the previous 1000. We're at 1500 total number of searches. For the 600 bytes, like I said, we got to look through the 600 bytes for the null character. And now the total number of searches is 2100. Move to the 700 bytes, add that 700 that we have to look through to the previous 2100. We have 2800. That's the total number of searches. And then talk about the 800 bytes that we have to join. You've got to look through 800 bytes for the null character. Add that together to the previous 2800 in terms of number of searches. And we have 3600 searches that we've done so far. Talk about the 900 bytes, right? We're looking now through 900 bytes plus the previous 3600, right? That's 4500. And then, of course, the last 100 bytes where we're looking through 1000. And that's how we end up with the total number of searches of 5500. Now, I hope it's absolutely clear as to why there's a performance issue with strcat as well as strncat. And so there were discussions about functions that could be used instead. And then there was a recommendation made to use memccpy. So looking at this function, if you look at the prototype, this returns a pointer to what we'll see shortly. And then you can see there's the restrict qualifier, which is used with each of the arguments, at least S1 and S2. When the restrict keyword or the restrict qualifier is used with arguments, what it implies is, and this is specifically with pointer arguments, what it implies is that there will be only this particular pointer that will be used to access that particular region in memory, right? Because remember, memory can be accessed by different pointers, but that particular region will only be accessed by this particular pointer. And this allows the compiler then to optimize the code. We then have int c. What that is, we will see shortly. And we have size c type n. This function copies bytes from memory region S2 to memory region S1, stops after the first occurrence of byte c is copied. Right? So the moment the character c is encountered, that's when the copy will stop. And a pointer is returned to the character just after c. Or the copying will stop after n number of bytes is copied. So this is whichever comes first, right? So either the occurrence of byte c or the n number of bytes. In case of overlapping, behavior is undefined. Now write code to concatenate two strings using memccpy. So we're going to go to code blocks now and we start a new file. Hashtag include stdio.h, hashtag include stdlib.h, and hashtag include string.h. Int main, and we're going to have two strings here, char root equal to, and then char root 1. And now we'll have a third array, and this will be in terms of size. It will be size of root plus size of root 1. Let's leave it at that for now. And we'll have char star end of concat That will be equal to concat plus size of concat. Right, so this will be showing us the absolute, you can see the last byte in concat, right? That will be that address, end of concat. We'll have size t, and we'll call this counter equal to 0. And then we'll have char star p equal to memccpy. Now this function memccpy is not as straightforward as strcat. You can't just use it. You need to put in a little more code to have it work, right? So we're going to have here the arguments concat, comma fruit, right? So this is our, you can say destination if you like, right? This is going to be our source, okay? And we are looking for C, which is going to be the null or 0, and size of fruit is going to be the number of bytes. Then we have another statement here which says P equal to memccpy, and now we have our arguments which are going to be P minus 1, that's referring to this pointer, right? So just the address before P. And then the second argument is a comma and a space maybe. And then we have the character 0 or null. And now the number of bytes is end of concat, that's the last byte, minus P. Right, so what's happening here is end of concat, as I said, is the last byte minus the last character, right, that was written into concat. Okay, or you can say the last character plus 1, in fact. Right, that's what is returned by memccpy. Then we check if P is not equal to null. Now we are going to concatenate the second string. So P equal to memccpy, P minus 1, right? And then we have the source, which is fruit 1 now. We are looking for the character null or 0. And the number of bytes is size of fruit 1. Right? So I hope this is clear as to what we've been doing so far. Then we can just print here, printf %s \n, comma, concat. Okay, and then we just have an exit 0 to end the program, right? Now let's run this and see the result. And you can see that our strings are very nicely concatenated. And so memccpy is what is recommended to be used for concatenation. Any questions on this? You can post in the comments. Now moving on. strcspn. The prototype, as you can see, returning a size t type, right? And arguments are const char star str1, that's a pointer, and another pointer to str2. Returns the index of the first character in the string pointed to by str1 that matches any of the characters in the string pointed to by str2. So in effect, it's going to return the length of a segment of characters that are not in str2, right? You can think of it that way as well. Accept two strings from the user, write code to print the index of the first character found in the first string that matches any of the characters of the second string. And then we have another exercise here, write your own version of strcspn. We're going to go to code blocks now and of course start a new file. And so hashtag include stdio.h, hashtag include stdlib.h, and hashtag include string.h. And then int main. And we'll have two strings here. So we'll have char root equal to, and we'll have char str1 equal to. We need an index, right? A variable that we'll call index to get the return value of the function. So what we're going to do is we're doing the first exercise, right? So we're going to use the function directly and then we write our own function. So here we'll have size t type, let's call that index. And then we'll say index equal to strcspn, passing in the arguments fruit, comma, str1, right? And then we printf found at index %d, comma, index, and printf, and here we say root of index. Okay, so it will give us the character or the first character that matches any of the characters in the second string, right? And of course exit 0 to end the program. Let's put a \n here as well. Now if we run this, it says found at index 0. So first character from fruit to match any of the characters in str1 is A. Right, that's the first character to match any of these. Right, now we can write our own function. To do that, we need to declare it here. So we say size t, that's the type it returns. And we'll have my strcspn. And the arguments will be char star s1, comma char star s2. Right, and here we say my strcspn. Now we can proceed to define it. So size t, my strcspn, and the parameters will be char star s1, comma char star s2. And within this function, what we'll do is we'll have a size t type, and let's call that return value equal to 0. Right? And we'll have two pointers, char star, let's call it ptr, equal to s1, and char star ptr1 equal to s2. Right? Now we say while star ptr is not equal to null, and here we say if, and we'll use strchr and pass in the argument, so that will be ptr1, that's the string we're looking in, for the character pointed to by ptr. Right, so if that character occurs in ptr1, then we break. Right? Otherwise, we increment our pointer. So ptr plus plus, right? That will move to the next character now in S1, remember, which in effect represents fruit, right? So it will move forward there, and ret val should increment by 1 as well, right? So that this represents the index which we can return here. So return ret val. Okay, so now if we run this, and you can see we got the same response. So now we've written our own strcspn version. Moving on. strspn, again this function returns a size t type value, and it takes as arguments const char and a pointer star str1 and star str2 as well. Returns the index of the first character in str1 that does not match any of the characters in str2. Modify the code previously written to report the index of the first character in string 1 that does not match any of the characters in string 2. I'm going to leave this with you, and I'll give you the solution in the next session. Moving on, strr, or str error, I should say. And this function returns a character pointer taking as argument something called error num. Where is that coming from? Returns a pointer to an implementation defined string. Now we can put in any number we want as error num, and the appropriate error will be displayed. But under no circumstances should we modify the string that is displayed. Now to show you a demonstration of how this works, I'm just going to run a very short program. That's it, just that one line. And you can put in, as I said, any number here. So if we run this now, you see you get a particular error displayed. You can change the number. You can put in 4 and you'll get a different error message, right? So you can use these error messages, and you can play around with this after the session to see the different error messages, right? Moving on, strpbrk. As you can see from the prototype, this function returns a character pointer and takes as arguments 2 character pointers. We have str1 and str2. Returns a pointer to the first character in the string pointed to by str1, which matches any character in str2. Right? So you may say that this is the same as strcspn. Is similar but not the same. Why? Because this one returns a character pointer. strcspn, remember, returns a size t type. If no matches are found, a null pointer is returned. Would null terminators be counted as matches? No, they're not. The null terminators are not taken into account. Okay. So I'm not going to write any code for this one. I'm sure you'll be able to manage it. This ends our session for today. In the next session, we will deal with mathematical functions. If you have any questions regarding character or string functions, remember you can always post in the comments. So till the next session, take care, stay safe. Bye.